Hello, everyone. Welcome to the Data Science Mentor program or a Data Science Mentor session. In this Data Science Mentor session, we're going to be looking at hyperparameters and model validation. If this is your first time on this session, the Data Science Mentor program is a cohort. It's a setup. It's meant for folks learning data science from scratch. And it teaches you data science with very simple examples and mentorship. The Data Science Mentor program has a whole lot of packages, recorded sessions that make it pretty easy for you to, follow it at a pace. And if you at any point need some mentorship for you to catch up or for you to make sense of what you're learning, that's what the whole idea is. It's mentorship as a service. Now, today we are doing, this is our 6th session. It's just a bit, let me pick up my annotator. So this is this is our 6th session. That's why you can see it over here. So we're doing hyperparameters and model evaluation. So we're going to be doing an intro to this. We've done a bunch of intros, first, second, third, fourth, fifth. So we've done some intros, introduction to machine learning, introduction to the scikit-learn APIs and their guiding principles. We've done very simple linear regression model. We just did use Python to do an intro. As we proceed, we'll just be talking about a lot of their intuitions. But at this point, we're doing a lot of intros and not deep dive. So we've done intros to classification, intros to regression, intros to clustering, intros to dimensionality reduction. Very simple fashion. And that's what we're going to do today with hyperparameters and model validation. My name is Pablo. I'm a host, convener, and founder of the Data Science Mentor program. Please feel free, right? And let's jump into this, right? So now the first thing we are going to do about talking about hyperparameters are we're going to break down a hyperparameter with respect to intuitions. Because intuitions are really, really super ways of understanding what you're learning. So I'll start off with this. So we'll talk about make hyperparameter our focus at this point. So hyperparameters. Now, the way I'm going to explain it is hyperparameters. Think about it like this. Say, imagine you're baking a cake. You are baking a cake. Next, a few things. Okay. Oh, sorry, let me confirm. The heading is different from today's topic. Oh my, so sorry, man. Validation. Model validation. Thank you so much. Right, so now if you were baking a cake, you would have to make certain decisions. For instance, part of the decisions you want to ask is how hot should the oven be? Another decision you want to know is how long will you bake? Well, that's the duration of the baking, right? Um, Another question you want to ask yourself is maybe how much sugar or flour should you add? How much sugar or flour should you add? Right. Now, all so if you are building a machine learning model, and remember, just like we said, right? For ML, we have look at what we have going on. We have inputs, which is data. We have a model, and we have an output. Excuse me. And we have an output. So now in ML, you have data, and which are the explanatory the explanatory variables, and you have the response variable. Now this model that is over here, you're looking to model it to a certain situation. Now because you have sklearn's library that has well organized algorithms in them, you're telling yourself, because there are different situations for that you're trying to predict, then you have to answer different questions. So you see what these hyperparameters are. There are these questions you ask yourself just to be sure what you're trying to do makes a lot of sense. Right. In machine learning, these decisions you take when building a model, right, are called hyperparameters. Right? So the decisions taken when building a machine learning model they're called hyperparameters. Remember, they are like settings, they're like knobs, right? So these decisions are like knobs. They're like knobs. You twist them, you're turning them. These decisions are like knobs. They are chosen before the training. We still remember that. They are chosen / made before the training. Now remember, the training is the activity you do to build a model, right? And after you've made these decisions, right, they control the model's learning behavior. So these decisions controls the model's learning behavior. Again, remember that if we were to use this analogy, this cake baking analogy, these decisions on how hot the oven will be, how long you will bake, how much sugar or flour should you add, will control the way the outputs, whatever it is you're baking, would come out. What you're baking for is bread. It will control how the bread will be like at the end of the day. So that's what it's like. But now enough of the regular one. Let's talk about the technical decision of a hyperparameter, right? Excuse me. Let's talk about the technical definition. The technical definitions are always important. So let's talk about a technical definition of hyperparameters. Now, hyperparameters are values that are set before a learning process. The learning process is how the algorithm learns your data. When the algorithm learns your data, eventually, becomes this model, right? So remember, we'll have different model parameters which are learned from the data, right? But you can tune a lot of the learning process. So again, just to set it up, right? Hyperparameters, these are parameters whose value are set before the learning process. Okay, I'm going to show you what that is in a bit. Set before the learning process. Now, again, the hyperparameters differ from model to model, right? And the way they learn from data, different things. So these are the things. So we're going to look at this. That's one part of it. Now, we've talked about this. Another thing I want us to look at is also, model validation, right? Model validation just tells us if our model performs well with unseen data, right? And I'm going to talk about model validation as we get into the stuff we're doing, and we are going to, as we talk about model validation, we are also going to talk about parameters itself. So that's why you see I brought two of them together, hyperparameters and model validation, so we can have both of them work together. So again, I am going to bring the data we're going to use. I am going to get them from sklearn.datasets, and I'm going to import load underscore iris. So this is like the iris data set, right? So we have this. So if I run this, remember when I mentioned it, we have, if you've not seen the earlier video we had on data representation from scikit-learn, this would be an interesting point, because the data we extract from here, which is the iris data, and in here I'm going to call this load iris. The data we get from here, if we put a type here, we have iris here. It's going to be an SQL object. But when I read it like this, iris, you see something's going on here. As a matter of fact, if I check the shape, sorry. No, I don't think I should have done that. Iris the shape. No. So you see that what we have here is it's like a dictionary, right? But it has the data, and in here it has the array of what we're looking for. And these arrays just typically like our iris data set, right? Then what we will do now make it make some sense is that you can see it over here. This is data, and put it to one side. And there's a part of this stuff we didn't see over here, which are the targets, right? So remember that we now have two types of data here. We're working with, we have two types of format. We have like the data side of it and the target, right? And remember, we mentioned the feature matrix and the target vectors. So that's basically, you can see a bunch of stuff in what we are doing. So that's what we have here. Now, for us to work with this, I would have to, first of all, introduce the X, which is, I mean, the convention for when we're looking at our explanatory variables, right? So here I'll say iris dot. And remember that we have this data part of it. So look at the two things. This data is the one that when we use X dot shape, this is the part where I should use my X dot shape. It will now tell us our n samples and our n underscore samples and n underscore feature. That's the part I wanted us to get to. And then y, which is, we would have here, is going to be iris dot target, right? And of course, you know that this y dot shape is just going to be n underscore sample, just one. So this is just a repetition of what we've done before. No. Now, what we want to do right now, so we have our data, right? The next thing I want to talk about is I want to talk about model validation before we go into it. And while we're doing these two things, we're going to now be looking at parameters, and at the same time talk about model validation. So here I'm going to introduce model validation and ask, what on earth is model validation? So here we're going to have model validation. So the question is, what is model validation? Now, again, let me try to pick up an intuition that would work. So you're studying for an exam using your school notes. So let's use this. You're studying for an exam. And what are you doing? How are you studying for exam? You are using your school notes. Using your school notes. Now, in an ML, in a machine learning speak, right, what you're doing is you're training. So it's like, what's going on here is like a machine learning situation, like you're training yourself, right? So you're training yourself. That's why you're using your school notes to do so, right? Now, remember that you want to be sure. You want to be sure that you typically you're sort of not learning stuff and just be like, and I'm learning and I'm going straight to the exam. So sometimes you test your understanding with practice questions. So you test your understanding with practice questions. And your practice, this is, do you know what you're doing here? You're doing a validation. You're doing a validation of your training. You want to be sure that it makes some sense. what you're doing. So this is the intuition behind model validation, right? Now, model validation will test how well you work with your own training validation as you're learning your exam. You're trying to test how well you may perform if you eventually get into the exam, you get to do the exam. For machine learning, it's basically test how well your model may perform when it sees when it needs to it needs to produce an output on data it hasn't seen. See that? You have to test these things. You just don't train stuff and then sort of like expect everything's going to be all rosy. What's happening in the real world is wild, so you can't. So you have to always test what you're doing. So model validation is typically saying, look, I'm training a machine learning model which has an output, which has an input, which is data, example data, information from the past, and I want to build a model. So when I see some new information, I can have that competitive edge and say that this makes a lot of sense. Now, but before you get into that, you typically must test what you're doing to be sure you don't just go out there and do stuff. Because out there is that term that is called production. It's a wild, wild west out there in production. Because in production, there are new things, there are edge cases, right? So, in this, again, so let's just do a technical definition. So this one is, let me call this is the intuition. Right? This is the intuition for it. And here, this is the technical definition. Now, with the technical definition, right? Model validation, I just mentioned it. Model validation tests how well your model performs on unseen data, right? Right. So, and this is done. Yeah. This is done. When I say this, validation is done. Let me call this validation so it doesn't look so passive. Validation is done before exposing the model to the real world, before exposing the model to the real world, So this is done. Now the question is, why is this important? Just like hyperparameters, because you have to tune things because you have different situations. Why is it important? Now, two things. There's one huge thing you always hear about, it's called overfitting. You overfit. Now, so there's a problem. Think about it. If you use your school notes to learn for so long, you get used to your school notes and you memorize your school notes. But when you now go to your exams, now because it's like surface learning, you're like learning stuff, but you're not thinking of how it's even going to be applied in many ways. So it's important. Overfitting is a problem, right? It's sort of like boost your confidence in your model and say this model can work, right? And you're being really objective with what you're doing. So that's sort of like very, very important stuff you do in order to make sense of the work you're doing before the work gets into production. So here is an example of when you build a model, right? And you train a model without validation. So here is a model without validation. Model without validation. Okay, sorry. This I cannot find. Where is? All right, here. This is model without validation. So we're going to build a model. Remember, with the guiding principle, the first thing is we get our APIs, right? So we start off by saying, so what we're going to use for this example, we're going to use something called the k nearest neighbor. The nearest neighbor class is a nearest neighbor classifier, right? So that's what we're going to use. Don't bother about that. We're going to talk about that in future. So from here, we say from sklearn dot neighbors. This is what this is. And so we import a k neighbor classifier. So where is the classifier? So it's typically going to because the Iris data set has targets that are categorical in nature or discrete in nature, right? So that's one. So we've got this. The first thing we do, we've got a model. Next is we need to fit our model. And so here we just create a model here, and in here we call k neighbor classifier. Now remember that this is where the interesting part comes, because we now have parameters. Look at that. Now these parameters are there, and there are some initial parameters. You can see the initial parameters here. They have initial parameters. All these parameters have assumptions, right? They make certain assumptions, right? And you'll make a lot of sense. It makes sense to understand this, why all these parameters are for. You can see them. Now, if the k nearest neighbor has an intuition it uses, right, in terms of sort of like using very interesting calculations, right? Using interesting calculations to vote what would make sense in terms of how to classify your response variables. Now, let's assume, right, that we're not going to be saying 5 neighbors, but by default, number of neighbors to use, say 5 neighbors. So we just decided, let's tune our parameter here and say n underscore neighbor, and I say let me use 1 instead of 5. That 5 is default. You could have seen that. So I'm using this. This is what I'm using. So I have tuned that parameter to it. Next is I'm going to fit the model. So which means to fit the model, I say model.fit. Again, remember, all this we're doing is the principle we've talked about earlier on. So I'll go through a little bit of that, just a little bit of stress here just to show you what I am doing. It's not new. The big world is that the machine learning problems. Yes. No, not here. Yeah. Oh, I must have gone so far off. Oh, that's wild. The guiding principles on what we're doing. And so this is what we do. We choose a class of the model, choose the model parameter by instantiating the class. Here, that's why we do some sensible defaults. And of course, we already know it's a feature matrix and the target vector. We've already done that. And then we now fit our model to the data and apply the model to new data, right? It's very simple stuff. These are like steps we're using for our scikit-learn estimator API, and we've already had that done. So let's go back to the bottom. So it doesn't look like it's something new, stuff we've done before, right? So now we fit the model, and what are we going to do? We're going to fit the model here. Now, there's something we haven't done, but if you watch the other videos, you're like, oh, isn't this when you split stuff? Oh, my goodness. Ha. But now we don't. We just go and take both set of stuff, and then we immediately fit the model, and say, okay, that's great. Then go on, let's create y underscore model, and then we predict. Then now, when we predict, so here we say model dot predict. Now, when I predict, I'm going to still predict with x. Like you can see, I fitted it here, and I'm still going to predict with it. So I predict. So now I have a model here. Now I want to now know, so how did I perform? So this is, when it's time for me to show how well I have performed, I now go and I import, I'm going to bring in the estimator, the scikit-learn estimator for checking how well I have performed. So here I say from sklearn dot metrics. So I import accuracy score. That's what I want. I want to see how well I have performed. Right now, before we see how well we have performed, you see that we're going to talk about performance metrics ranges from 0.0 to 1. It's like 100%, right? So it's like from 0.0 to 1. 1 is 100%. It means you're good. So you have like 0.1. It's like, that's so good. So we want to check how well we did. So to do that, I'm now going to take accuracy score, and then I'm going to take the y. Remember the y, which is the target, right? Which is our explanatory variable. If we come over here, when we started, this is our target. See it? We take the y, and we now say, look at what I have predicted and tell me if there was a connection. Give me a percentage of how well I have done. So I say, well, after I've done this prediction here, and it says, okay, sure, I can do that. So I'm going to tell you from 0 to 1 how well you've performed. So I run it, and it tells me you have performed 100% accurate. Now, 100% means the model was able to predict, using the explanatory variables, it was able to predict all the response variables, right? Now, this is not even possible in reality, right? That to expect a model to have 100% an accurate prediction. Now, there is an approach for how to do this, which means you need to do something right. Right now, in our next session, we're going to talk about that. So here, what we've done is an intro to it. In the next section, we're going to ask ourselves, why is it ideal, right, to validate really well? Or should we do it in our next session? We should just do it right now. Okay, let's do. Let me see. Do I have enough time? Okay, no. Okay, let me do it right now instead of splitting it. Then in the next session, we'll just basically do we start to look at a little bit of technicalities. So here, let's now talk about model validation. Right. Now, I'm just saying model validation. Right. Now, you can a better sense of understanding your model is looking at the data, not actually training the same data. The same data used to train. You train the data with the response and explanatory data, and then now go to now find out how you perform with the same thing. It's basically going to be like, I know this information, I know the data, right? it's like you use practice questions over and over again. You know what you're doing. Or rather what you do is not practice questions. The training questions you use them to test yourself to know how well you're performing. You're going to memorize them at a point. Now, with validation, right, you create a system where you hold out some information, right? So that's why there's something called a hold out set, right? So you create a holdout set. Here, you set some data apart, right? So this is basically what you do. You set some data apart, right? So that's what you're going to do. Now, when you set this data apart, then you can now train your model with one part of the data and now evaluate how well it performed with the data that it hasn't seen before. Now, to do it, again, we will now say from sklearn dot model selection. Then we import. One of the first things we're going to learn, but we're going to improve on this as we proceed. But and I have done this before, and I'm sure if you've watched simple linear regression or simple classification models, you see that I use that. I use the train test split. So what it does now is that we're going to split our data, and then we split it. We could do a 50-50 split. So let's do a 50% split. Yeah, so that's what we're going to do. So that means we use half of our data to train and half of it to know how well we've done. To do this, we already have X, right? So what we're going to do, we're going to have X1 and we're going to have X2. We're going to have Y1 and we're going to have Y2. That's what we're going to have. Now with train test split, we're now going to bring in X. Remember where X is at? X is this guy over here, the iris data, which is explanatory variables, and the response variable. Now we bring them in here, and then this split is going to happen, right? We're going to have a random state of 0. So even if we're going to do a reproduce it, we can still use maybe 20% with another random state of 0. And if we want to do some replication that we want to work, we can switch it and see what will happen in a different state, right? So here we can also get the train size, and with train size from 0.5, we say it's 50% of it. So now you see what we have. Now remember that before I run this, when we did this, you can see their shapes. Now when we now run this over here, that means x1.shape should be half of 150. It's only intuitive. Now let's fix the model. Remember, without validation here, model without validation, we did X and Y. We fit the model X and Y without bothering much, right? Here, we're now going to model.fit, and instead, we're now going to take X1 and Y1, and we'll train it on this. And so that's 50% of the data, right? So that's what we have done here. Next, we want to now evaluate how well the model has performed. So we say y2 underscore model here, because here we want to do the prediction. So in here we say model dot predict. So remember now, what we're going to do is we're going to predict with x2 because it hasn't seen x2, right? So we're going to predict with the other 50% of the data. So it's x2. We're going to do that. Now we now run this prediction. Now, when we now want to know how well we have performed, we now say, let's pick up our accuracy score. And in here, we're going to say, we were going to look at Y2, which is the 50% of what we haven't seen before, right? And then look at the one that was just predicted here, which is Y2, and say compare. We're going to compare with the values that we haven't used before, that it's been already predicted, which is there. And we're going to now look at the one we just predicted with. So like actuals and predicted, the actual scenario and the predicted scenario, and say, let's see how well this performed. So when we run this, you see, oh, this time around, we have 90%. And it's no longer 1, but now it's 90%. Isn't that interesting? Now, at this point, right, what we have tried to do is we've given you an inkling that if you're building a model, as much as you would switch the nodes as you perform stuff, it's also ideal for you to separate them so as to validate how well you've performed, right? Now, we're still not done. We're still going to look at there's another way, another type of validation. We need to talk about that validation, that level. And so that's what we're going to do in the next session. So right, so this is what it is. So if you're watching this live, please feel free to drop a question. If you are part of the data science mentor program, feel free to drop a question. And if you're watching a recorded session, please drop a question in the Telegram channel. Thank you.